Welcome to the Explainer. There's this one thing that really separates a mid-level engineer from a senior one. It's thinking in terms of scale. It's all about being able to answer one huge question. How do you actually take a system from just one user to millions? Well, today, we're going to map out that exact journey.
So how do you do it? It's a massive challenge, for sure, and being able to solve it is pretty much what defines senior-level engineering. But you know what's funny? The path to supporting millions of users actually starts somewhere incredibly simple.
Yep, that's it. You start with just one. It sounds a little crazy, right? But every single massive, complex system you use every day, I'm talking social media, streaming services, all of it, started with the absolute basics. So let's start our journey right there, too. Okay, so this is ground zero. This is the day one setup. Just picture one single computer doing everything. It's hosting the web app, it's running the database, it's handling every single user request that comes in, the whole shebang on one machine. At its core, this is how the entire web operates. It's a pretty simple flow, really. A user types in a domain name, the DNS acts like a giant address book for the internet to find the server's real address, its IP, and then a direct conversation starts between the user's browser and that server. This little dance is the foundation for everything we're about to build. And here's where we hit our first hurdle. This all-in-one server, it's super efficient when you only have a few users. But as soon as your app starts getting popular, it gets overwhelmed fast. And boom, we've just found our first bottleneck. To grow, we've got to start separating our components. And the most logical first step is to pull out the data layer, the database. Give it its own dedicated server. But doing this leads us to a really critical choice that's going to shape the entire future of our application. And listen, this isn't just some small technical detail, this is a foundational decision. The type of database you choose is going to directly impact your system's performance, its structure, and most importantly, its ability to scale down the road. Okay, let's dive into this. On one hand, you have the super structured, reliable world of SQL databases. Just think of them like perfectly organized spreadsheets. Everything has a place. On the other hand, you have the flexible, hyper-scalable universe of NoSQL, which handles data more like a collection of individual documents. So this all comes down to choosing the right tool for the job. If you're building a banking app where data integrity is absolutely non-negotiable, you're going to choose the consistency of SQL. But if you're building, say, a social media feed, you'll probably trade some of that rigid structure for the raw speed and flexibility of NoSQL. Great, so our database is now on its own dedicated server. But what about our application servers? As traffic keeps growing, we're going to face the next classic engineer's dilemma. How do we give them more power? This leaves us with two very different paths. We can go with vertical scaling or scaling up. That's where we take our existing server and just make it a super-powered heavyweight champion. Or we can do horizontal scaling, scaling out, where we build an army of smaller servers that all work together. Now, scaling up seems simpler at first, right? But you quickly hit a hard physical limit. You can only make one machine so powerful. And more importantly, you've just created a massive single point of failure. This isn't just the technical problem, it's a huge business risk. If that one server fails, your entire application just goes dark.
So, we decide to scale out with our army of servers. But this creates a totally new problem. It's a coordination problem. When a user sends a request, how do we decide which of our many servers should be the one to handle it?
And the solution is something called a load balancer. It becomes the new, single front door to our application. You can think of it like an intelligent traffic cop. It stands out front, looks at all the incoming requests, and routes them to the best available server, making sure the workload is spread out evenly. And this traffic cop has several strategies up its sleeve. The simplest is round robin. It just goes down the line of servers one by one. A smarter approach is least connections, where it sends traffic to the server that's currently doing the least amount of work. And then you have methods like IP hash, which are critical when you need to make sure a specific user always lands on the same server for their entire session. So our system is now way more capable, but it's also way more complex. And with all that new complexity, we've accidentally created some new, hidden weaknesses. A single point of failure, or SPOF, is the Achilles heel of any system. It could be our database, or, you guessed it, it could be our brand new load balancer. I mean, think about that for a second. All of our application servers could be running perfectly fine, but if the one component directing traffic to them fails, the entire system is down.
Identifying and getting rid of these SBOFs is a core task for any senior engineer.
So the strategy is to build resilience through duplication and automation. We don't just have one load balancer. We have a backup ready to take over at a moment's notice. We constantly run health checks to monitor every piece of the puzzle, and we build systems that can automatically replace a failed component without a human ever having to intervene.
And this right here is maybe the most important takeaway of all. Understanding these diagrams is just the start. True expertise, the kind that gets you to a senior level, comes from practice. It's about getting your hands dirty, setting up a server, configuring a load balancer, and actually seeing these concepts come to life. And that's really the core of system design. It's a continuous cycle. You solve for traffic with load balancers, and you solve for failure with redundancy. But as you grow, another part of the system will become the next weak link. The job is never truly done. It's a constant process of identifying and solving the next challenge to keep your application running smoothly for everyone.